Okay, I think we can get started now. So again, I'd like to thank you all for joining us in this webinar, in which we'd like to talk to you guys about using the ELK stack for security analytics and security operations. My name is Daniel. I'm a product marketing manager here at Logz.io, and what we're going to go over in the following 30 or 40 minutes or so is first some of the challenges organizations are facing today with security and how specifically the ELK stack can help overcome some of these challenges. We'll take a look at where the ELK stack falls a bit short and where Logz.io security analytics module, the module that we've added on top of the ELK stack, can actually help. We'll have a few minutes at the end of this webinar for questions. So if anything pops up during the webinar, feel free to just type it down in the webinar chat, and we'll do our best to answer these questions, time permitting, of course. Okay, let's get started. As you all know, cyber threats, data breaches, and even compliance requirements are pushing more and more organizations towards implementing tighter security controls. But the growing need is actually running up against one simple fact, and that is that securing modern IT environments is complicated. Well, security was never easy, right? But what makes it even more difficult today in the era of cloud computing and microservices and distributed environments is the very nature of these modern IT environments that we're trying to secure. Well, first of all, the amount of data these environments are actually generating is huge. It's not just the collection of the data that you need to think about, but it's its storage. You want to comply with PCI, for example, so you're going to have to think about retaining data for a whole year. So we're talking about huge data pipelines that need to be configured and handled. Of course, environments are now much more complicated. So cloud and containers, container orchestration platforms, even serverless applications now are spread across multiple regions, services, sometimes across different clouds. And this distributed and dynamic nature of these environments is an operational challenge, of course, but of course it's also a challenge for security analytics and security operations. Now, security is a very specialized field and requires a very specific set of skills. The truth is that there are not simply enough people out there with this specific skill set. I think I saw an estimation by Gartner estimating that there's about one security person for every 5,000 people in organizations. This is a nice estimate as to how scarce security talent actually is. Another challenge that we need to think about is the actual number of tools used for operating and securing IT environments. So SIEM systems, right, will live alongside other security tools that you're using, and you've got your infrastructure, monitoring, moving bits and pieces. So all of this adds to a lot of this complexity. And maybe as a result of this tool sprawl issue, teams will end up handling a huge amount of alerts, right? And you've all heard about the concept of alert fatigue. So the result is a high signal to noise ratio, and the end result is that a large number of false alarms simply overwhelm teams. And we'll see a nice example of this pretty soon. And last but not least, definitely worth mentioning here is the challenge of open source. So more and more open source code, right, is being used for building these modern applications. And this introduces a whole new set of security vulnerabilities, and has also given birth to a whole new set of tools and a whole new ecosystem of solutions for open source vulnerability scanning. Now, there are, of course, a lot of systems out there already that can be used and are used, in fact, and specifically SIEM solutions, right, for securing environments and meeting compliance standards, etc. But these solutions are great at collecting different events from the different layers of an environment, giving us the tools we need to perhaps correlate between different event types, get alerted on these events and then giving us the tools we need to actually act and remediate any incident that's detected. The problem is with some of these SIEM systems is that they're not a great fit for modern setups and modern IT environments. Why is that? Well, first of all, a lot of these solutions are often pretty costly, difficult to procure, difficult to deploy and integrate with and maintain over time. Some organizations will actually end up exhausting huge amounts of time and resources just to implement these systems, and the actual ROI down the road is pretty low. And we mentioned alert fatigue before. These solutions currently, as they are now, they lack the analytical sophistication needed to actually take care of that high signal to noise ratio. And what they'll actually do is the opposite. They'll cause too many alerts, right? Which will result, as we already talked about, inaction and alerts just going unnoticed. And another common complaint that's usually sounded against these legacy SIEM systems is that they're not a great fit for cloud architectures, which are, again, like we said, highly distributed, highly transient in nature, and require flexibility and, of course, scalability. So these legacy systems are usually slow, a bit sequential, implemented in siloed environments. It's just not a great fit for the whole concept of modern DevOps methodologies. So you guys might have heard about this, and I like using this example just to drive the message a bit further. A few years ago, Target was breached, and the security team, believe it or not, actually had a nice alerting system in place, and they had alarms alerting them on that specific breach. But guess what? The InfoSec team responsible for these alerts, for monitoring these alerts, actually ignored the alerts. Why? Because they had too many. So circling back to those challenges we just spoke about, securing modern IT environments requires a very specific type of solution, because traditional solutions simply not built to deal with the distributed and transient and noisy nature of these environments. Right, so where does the ELK stack come into the picture? Well, logs, of course, and you guys probably all know this, they lie at the heart of almost any SIEM and security analytics solution in the market, simply because they contain a wealth of information on the different events taking place in an environment. And there's a long list here of log types that need to be actually used, collected, and logged for security. Starting on the application level, and then you've got your servers and infrastructure, different security controls that you might have put into place, like firewalls, and then of course you've got your network sources, and all of these logs need to be taken care of, right? They need to be collected, they need to be processed and normalized, enhanced, and of course stored. And these processes are grouped together under the common umbrella term of log management. And this explains why the ELK stack, or as it's been renamed these days, the Elastic Stack, is increasingly being used for security analytics and security operations. Just in case some of you guys are new to ELK, a brief explanation on what ELK actually is. So ELK is actually an acronym for the three main building blocks comprising the stack. The E, of course, stands for Elasticsearch, the heart of the stack, a full text search and analysis engine based on Apache Lucene, completely open source, of course. Strong focus on search capabilities and features, so the easiest way to interact with the data stored and indexed in Elasticsearch is using an extensive REST API. This API is probably one of the reasons why Elasticsearch is such a popular database. Elasticsearch was also designed to be scalable, pretty fast, and boasts pretty good results even when storing and searching across millions of log messages. The L in ELK stands for Logstash, so the stack's workhorse, if you like, in charge of aggregating the data from the different data sources, processing that data, enhancing it, and then sending it on down the pipeline usually to be indexed in Elasticsearch, but sometimes it might go through other layers in an architecture, and we'll talk a bit about that later on. So actually the role that Logstash plays in any operations or security operations stack is very, very important, because that's the component that's going to help you normalize data. The K in ELK stands for Kibana, basically the stack's user interface that you can use to query the data, search it, and build beautiful dashboards to your heart's delights. We can't talk about the ELK stack without mentioning a fourth relatively recent addition to the stack, Beats. So Beats is a family of log shippers, lightweight data shippers, used for shipping different types of data. In the context of security operations, you'll probably be using FileBeat, one of these beats. So FileBeat will track log files and send that on to Logstash for further processing. And together, these four different components of the stack really act natively and nicely together. They work pretty good together, easy to set up, and really provide us with a nice, powerful, and effective solution for log management. Now, there are plenty of proprietary log management solutions out there. So you might have heard about Splunk. Splunk, a company who virtually invented the term of centralized logging and log management, been around for quite a while. They self-attest that about 15,000 companies use them. When you compare that to the amount of companies using the ELK stack or the Elastic stack, it's a drop in the sea. Just understand how popular the ELK stack is. Some interesting stats here. So the different components in the stack have been downloaded over 100 million times since around 2005. Maybe more interestingly, Elasticsearch is the second most downloaded open source platform out there, second only to the Linux kernel, believe it or not. And we're talking about millions of pulls, of course, from the Docker Hub. So interesting stats by any account. Why is the stack so popular? Well, of course, it's open source. All the reasons we like to use open source tech. Helps us avoid vendor lock-in. It's free of charge, a large community backing it, helping us stay up to date with new features, new technology. It's also relatively easy to set up and start out with. Anyone can get an ELK stack up and running with one simple Docker compose command. Of course, it's not that simple down the road when data pipelines get more complicated, more packed with data. We'll see why soon. But to get an initial pipeline of logs flowing is pretty straightforward. And it's a powerful platform, right? So you've got Kibana's analysis capability coupled with Elasticsearch's REST API, great performance, like I said, even when searching and storing millions of documents. So pretty powerful offering. In terms of use cases, so we said ELK is used mostly as a log management and log analysis tool, but also as a search backend for websites. There are other use cases, of course, that are worth mentioning, like business intelligence, technical SEO for marketing. But like I said, it's also being used as a security solution as well. And you'll see a lot of the new security analytics tools in the market, both proprietary and open source solutions, actually bundle the ELK stack on the back end because of the log management and log analysis capabilities that the stack brings to the table. Okay, so how does the ELK stack fit into security operations? Well, to collect the logs from the different data sources, these could be servers, could be containers, could be applications. Like I said before, you'll most likely be using FileBeat. So for example, if you're using Zeek for network monitoring, Zeek generates a long list of log files. So you'll collect these log files using FileBeat. And then FileBeat will forward these Zeek logs into Logstash. Logstash will help you transform, normalize, process this data, and then send it on into Elasticsearch for indexing, where the data resides. And then, of course, you'll use Kibana to actually analyze the data, create dashboards, etc. for your SOC. Sounds great, right? But the question is if this is enough to overcome the challenges that we started this webinar with. And to answer this question, what I'd like to do now is go over some of the basic ingredients that you'll need in any solution for security analytics. So first, of course, any solution that you use is going to have to be able to collect and aggregate data efficiently from multiple layers, multiple data sources. More importantly, definitely the solution has to be able to process the data, normalize it across the different data sources that the data is being collected from. Of course, this goes without saying, your security analytics solution will have to be able to handle storage and probably extended retention, and hopefully retain this data in a way that doesn't bankrupt your organization. Naturally, any security analytics solution has to provide you with the tools you need to analyze the data. So at a minimum, this will mean the ability to query the data, search it, and build visualizations. Ideally, and this is important, increasingly becoming more important as the years go by, the solution has to be secured tightly to help us comply with regulatory standards. We'll want our solution to be able to send out alerts, notifications when a specific security event is actually recorded in the system. And this is coupled tightly with correlation rules that help us actually, well, create a story. So connect the dots, identify if there's a suspicious or malicious sequence of events. So correlation rules are, of course, a very important ingredient in security analytics and security operations. And last but not least, ideally, the solution has to be able to help us become aware of possible threats, just so we're better equipped to defend our organization, or in other words, threat intelligence. Looping back to the diagram from before, we saw that ELK can help us out with a lot of these key ingredients, right? There are plenty of integrations out there between the ELK stack and open source and commercial security solutions. But if we take a closer look, we might see that ELK falls a bit short in regards to some of these items on that checklist. So let's take another look again. ELK definitely is a great platform that will help us collect and aggregate data from the multiple data sources that we have in our environment. We can use Beats, Logz.io, we talked about this before. Logz.io will also help us process the data, normalize it. Elasticsearch takes care of the storage element, highly scalable, will enable us to store the logs, index them over time. Kibana is a great tool for analyzing the data. It's renowned for its visualization capabilities, and we'll take a look at a couple of examples later on of these kind of dashboards. Now, security and compliance, this is where things get a bit tricky. So yes, vanilla ELK does support various security features, so encryption, user control, but you've got to remember that these need to be configured and added on, and sometimes even paid for. And B, we're talking about pretty basic functionality, so they might not be enough to help us comply with regulation standards. Alerting is also not provided in vanilla ELK or out of the box, so also requires some extra configuration adding on. And correlation rules and threat intelligence, of course, are not provided as part of the open source ELK. So some key requirements that we talked about are missing in the ELK stack if we want to leverage it for security. Yes, we can use other tools and to complement the ELK stack, and we mentioned some of these before, like Zeek. There's also other great open source security tools with Zoo, OSEC, Suricata, Snort, etc. But another challenge that we definitely need to be talking about in this context is the challenge of scale. So yes, ELK stack is a great log aggregation, great log analysis tool, but in large deployments can definitely become somewhat of a headache to maintain. And this is because other than installing Elasticsearch and Logstash and Kibana and Beats, you also need to add some other elements into your architecture. So first of all, pipelines need to be resilient, and because Logstash and Elasticsearch are pretty susceptible to load, you need to think about adding some kind of buffering mechanism into your pipelines. Of course, the architecture needs to be scalable, highly available to make sure data growth and data bursts don't crash your whole pipeline. And we mentioned this before, you need to think about how data is retained for extended periods of time. And this is especially true for the security use case in a way that doesn't max out your Elasticsearch clusters or your organization's bank account, so to speak. So here's just a general idea of what this could look like. So suddenly that simple diagram that we saw before is a bit more complicated, right? We've got Kafka here acting as a buffer in front of Logstash for data resiliency. As you can see, we're using Elasticsearch clusters with 5 nodes each, 3 master nodes, 2 data nodes. We're using all sorts of different other components to complement the vanilla ELK. So we've got Curator to delete old indices. We've got archiving to an S3 bucket set up. We've installed ElastAlert to handle alerting. We're using Nginx as a reverse proxy for authentication. And of course, we've replicated this whole thing, this whole architecture across 2 AWS availability zones. So yes, this is just a recommendation. Every team, every org is going to be a bit different, but these are the basic ingredients that you're going to need to make sure your ELK stack is actually production grade. So as we saw, there are some challenges involved in using the ELK stack for security. And what I'd like to do now is explain a bit about Logz.io's approach and how our security analytics module helps overcome some of these challenges. So first off, just in case you've never heard about Logz.io before, we provide an intelligent and scalable machine data analytics platform that's built on top of the ELK stack, and we provide the stack as a fully managed service. Logz.io security analytics will actually allow users to reuse data used for the operations use case for security as well. And what this means is that you can use the same tool that you're using to monitor your production environment for performance issues and troubleshooting, etc. You can use that for security threats as well. So you ship your data once and then you use it for this dual use case. So there's no need for context switch and using multiple tools. Provide built-in integrations, virtually any data source. And we also provide 24/7 in-app support to help you out with the process of shipping data and parsing that data. We've also added some of those additional bits and pieces that we said are missing in the ELK stack, such as threat intelligence and rules. And we also offer built-in reports and dashboards for various compliance types and different security scenarios. And again, all of this is offered as a fully managed service with automatic scalability, high availability, and security and compliance built in. So what I'd like to do now is switch over to the platform and provide you guys with a short demonstration of what this actually looks like. Okay, so we'll start with the basics. Like I said, Logz.io Security Analytics is based on the same data set that you're using already for operations. So all the security capabilities that I'm going to show are applied to one data set shipped into the platform once for operations. Now, if you need to add another data source for security analysis, Logz.io integrates with pretty much any data source. We've got a variety of different data shippers, appenders, and other native integrations that you can use. And like I said, we will automatically process this data, and we also offer 24/7 in-app support to make sure that data is normalized properly. Like we said, normalization, very, very important ingredient in any SOC. So you might have, if it's your firewall or maybe an IDS that you might have deployed, or AWS Guard Duty, will help you with collecting that data, indexing it, of course, regardless of the volume, and, like I said, parse that data. Now, once you've shipped that data into the platform, you can begin your security analysis by switching over to Logz.io security. So you're immediately provided with this summary page. This page is actually a comprehensive dashboard that gives you a nice security overview of your environment for the last 24 hours. So you'll be able to see an overview of the different types of events that have been taking place in your environment. These could be access events, audit events, threat events, etc. You can see the origin of these events, breakdown by severity, trend over time, and so forth. We can actually investigate individual events using an investigate feature that will lead you to an additional dashboard, and that's probably a topic for another webinar, but definitely a useful functionality in the platform. Now, these events that you're seeing in this dashboard are triggered by correlation rules, and this is another core feature of Logz.io security analytics. So if we open up one of these rules just as an example, so you'll see that they're actually a set of conditions that, if met, trigger an event, and they're based on an Elasticsearch query and a bunch of other conditions that you can fine-tune and define. As you can see on this rules page, the platform already ships with pre-configured rules for different attack vectors, security use cases. So you can actually just search for a relevant rule and then enable them, disable them, edit them, fine-tune them as you see fit. To create a new rule, it's pretty simple. You're gonna head back or head to the Discover page, and this, anybody who's accustomed to using Kibana, the open source Kibana, will recognize this user interface. So you use the Discover page to query your data, and then you just hit the Create Rule button, and then set the different conditions and definitions for the rule. Another nifty feature that's worth talking about is lookups. So lookups will allow you to easily create reference lists for using in your correlation rules. So for example, you might want to create a rule for failed logins into the Amazon console, AWS console, right? So instead of manually configuring a long query in the rules definition, you can just reference a list, a pre-made list that's updated and maintained more easily. Okay, next up, the threats page. So the threats page provides you with threat intelligence on malicious activity and potential attacks. So behind the scenes, what's happening is that Logz.io security analytics is crawling a bunch of threat feeds, public threat feeds, and correlating the data with your logs. So if a correlation is identified, a threat is then flagged in the platform, and the log is enriched with additional security context that you can use. So you can monitor the threats per feed. You can see the most active geographic location, severity breakdown, etc. The last feature I wanted to talk about briefly is reports. This is a relatively recent new feature that we added, and definitely a necessary element in any security operations or security analytics platform. Reports is in essence a snapshot of a Kibana dashboard. So you can now automatically create and share one of these snapshots of a dashboard on a set schedule automatically. So again, like I mentioned this already, Logz.io security analytics is built on top of the ELK stack, right? So you can use all of the analytics capabilities available in Kibana to query the data, build visualizations and different dashboards. I mentioned this as well. We ship with different pre-built dashboards for different compliance scenarios, different security use cases. This one, for some reason, is not opening. let's try a different one. Okay, so this really helps you streamline the process of building and using Kibana for monitoring your environment. Okay. So just to sum things up, yes, the ELK stack is indeed a powerful log management, log analysis platform. And as we said, more and more teams are using it for their SOC. But as we saw, there are also some challenges here that we need to think about. So first of all, we need to add some core functionality that's missing to make it suitable for modern security analytics. And of course, we've got to make sure that our system is production grade. So a lot of time, a lot of resources need to be put in to actually make the ELK stack production grade and make sure if we're using it for security that the system is robust enough to handle large amounts of data. All right, so we're nearing the end here. Before we turn to some questions, just some links here to help you guys out. Our blog, for starters, great information on using the stack for security, the ELK stack for security, and also about other security-related issues. I definitely recommend taking a look at our cloud security blueprint. It's available on our website. Anybody can access it. Some really good best practices and tips for implementing a multi-layered security approach for securing a cloud environment. And of course, Elastic's documentation is also a very good resource for technical information on setting up the stack and using it. It's also worth mentioning our free trial. It's one of the more generous ELK free trial experiences out there. So we actually offer up to 3 GB of data per day, 3 days retention, and a lot of the functionality that you just saw in the platform as well. So definitely worth taking a look at if you want to start playing around. Okay, time for questions. So I can see we have got quite a few here, so we better get started. I'll try and answer them all, but I can't promise you that I will. So let's get started. Question 1. What log types do we need to collect for security analytics? Okay, so we talked a bit about this before. This will highly depend on your environment. At the very least, I think we're talking about first about your network layer. So VPC, DNS, routers, etc. Then you've got your security layer. So if you've put a firewall in place, you might have an antivirus that's generating data. You've got your infrastructure layer, operating systems, servers, databases, and then of course you've got your applications, right? So you know what, I mentioned the security blueprint that we have on the website, so that kind of details that for you, so feel free to take a look. Okay, moving on. What's the recommended way of installing the stack? I assume you're referring to the ELK stack. Can we Dockerize it? Yes, you could definitely Dockerize the entire stack. You can also orchestrate it with Kubernetes. A lot of different ways to install the stack. I think the most common way that I've seen people installing the stack is on EC2 instances on Amazon. I guess it's just easier to scale. You've got those on-demand resources, pay-as-you-go model, etc. So yeah, that's by far the most common way for installing the stack. Do you integrate with AWS Guard Duty? Yes, I mentioned this before. We do indeed have an integration with Guard Duty. I think, if I'm not mistaken, it involves tapping into a Kinesis stream. So yeah, we definitely provide. We also have pre-made dashboards for Guard Duty as well, and correlation rules, etc. So yes, we have a nice integration with AWS Guard Duty. Okay, one more question. How does your threat detection work? So basically, any IP that you have in your data that correlates with the IPs listed on the malicious IP lists that we use are flagged. So we use, for example, Alien Vault, so reputation list, block list DE. It's simple as that. So once there's a correlation identified, then it's flagged in the system. We have got a question here. Does Logz.io integrate with StackState? I'm afraid I'm not acquainted with StackState. I can say that if StackState generates log files or any other kind of output, we have built-in integrations for any data source. I'm sure it's not a problem. Just that needs to be worked out. Okay, we're going to have to wrap this up now, I'm afraid. Again, I apologize for not getting to all the questions. We've got a record of these, so we'll try and take this offline and get back to you with answers. So again, thanks for joining us, and hopefully we'll see you in our next webinar. Have a great day.